A fireball lights up the sky over New Zealand. People see it, cameras catch it. Someone even hears the sonic boom, and within hours a small group of people realise something incredible. A meteorite might be sitting on the ground, waiting to be found.
Percent is 0.9.
Oh wow.
No way!
This impossible story actually occurred in New Zealand in 2024.
Our Meteor camera network had been operating for about 2 years with the goal of observing fireball events and potentially finding a meteorite. On the 13th of March 2024, we had this big fireball. We also had some people report hearing the boom, which is a very good sign. It means it's come down quite close to the Earth's surface, and was also observed by many of our cameras in the camera network. And one of our camera hosts, Denis Behan, was sitting in his spa pool in Queenstown, and he was looking out and saw this fireball come in, and he's sitting there next to his camera that's also looking in the same direction. So he got out of his spa pool all excited, ran inside, let the network know through our email list, and then by the end of that night we had an initial trajectory calculated for this fireball, and were able to determine that it probably dropped a rock. You'll see here we've got the camera stations that have contributed to the observations of the fireball. So you can see this is where we started to observe the fireball, about 90 kilometres high above Earth's surface, and at that time it was going 18 kilometres per second. So that's where it started. We tracked it all the way down as it slowed down to where it went dark. It took about 6 seconds. That's still about 25 kilometres high, and then from there we have to model how the rock made its way to the ground.
Can you actually find something that fell from space somewhere out there in the landscape? New Zealand isn't exactly easy terrain. Dense bush, mountains, rivers, and a huge ocean. Most meteorites that land here are lying somewhere hidden far from sight.
At this point it's still going 5 kilometres per second, but it slows down very quickly and reaches terminal velocity at about 200 kilometres per hour. And at that point, it's basically just a rock that's falling vertically through the air. It's kind of like if someone was up there in a helicopter and dropped a rock. So we have to work out whereabouts on the ground that rock might have been. And there's uncertainty in weather conditions and how big the rock is. There's this zone that runs from about masses of 1 gram right up to masses of about 1.5 kgs.
So now you've got a target, but it's not a point, it's a zone. Somewhere across that huge area there could be a dark fist-sized rock that just arrived from space.
When we were deciding how to search for this, we thought it was something that was about 1 kg, and also you're not going to go and look for a 1 gram rock. That would be too small. So we decided to just focus in on this upper end here where the masses get up above 100 grams. The event happened on a Wednesday. We had an initial trajectory that night. We decided, right, we'll go and check it. We'll do a quick bit of reconnaissance. So I went out there and had a look just to see, how are we going to get in there for a bigger search, and how are we going to actually go about the search, and is the ground worth searching? Fortunately, this rock landed on some river flats near Tekapo, and the ground was just basically grey and flat and like a desert, and so you have a light coloured background to look for a dark stone. It was as good as it gets for looking for meteorites in New Zealand. Then we decided, right, this is going to be good, we can set up a public search. I'd done a bit of planning and figuring out how we're actually going to organise people and get them on the ground, and I talked to a friend who works for Land Search and Rescue, and they have established methods They grid out the area on a map, and then they'll split up into teams, and each team goes to one of the boxes in the grid, and they systematically search through that box. That's the way the search was supposed to go, was there were supposed to be groups going to boxes, clearing boxes, and then eventually we'd maybe find the meteorite. We ended up with 20 or so people who turned up on the day, and we went out to do the search. But as the groups were walking out to their first search boxes, one of the groups sent me a picture, and I was sitting in the car. I saw the picture and I was like, no, it can't be, not already. Like, we're only 15 minutes into the search.
Now this is the part that doesn't make sense. They planned the search, they mapped the area, they organised teams, and before the search even properly began, one of the teams just walked right up to it. It should be impossible, but it actually happened.
They're quite distinctive meteorites because they have on the surface a melted outer crust that's very thin. It's less than 1 millimetre typically, and we call that the fusion crust, and that forms during that fireball phase of its entry where it's pushing into the atmosphere. It's moving so fast it creates this high pressure zone in front of the rock that we call it ram pressure, and when you pressurise air it heats up, and there's so much heat during that pushing that the outer surface of the rock melts, and that's really the key identifying feature that we use when we're trying to determine if a rock is a meteorite, does it have a fusion crust? And in most cases the fusion crust is dark and black, and then if you can see the inside of the rock, the inside is pale, so you'll have a dark outer fusion crust with a pale inside. That's sort of your typical stony meteorite. I also sent a picture to James Scott. He's the major driver of setting up Fireballs Aotearoa across New Zealand. And we both sort of agreed, yes, this is a meteorite and it's exciting. And then I also had with me a X-ray fluorescence spectrometer, a portable field one, and we analysed the rock in the field. And with most meteorites, they should have quite a lot of nickel, so we're looking for stony meteorites, it's about 1%, and I did 2 tests on the rock and it came back at about 1% nickel.
Yeah, nickel, that's almost at 1%, it's 0.9.
Oh wow.
Yeah.
And yeah, it turned out to be the meteorite. And there were a lot of smiles and a lot of celebrations, and yeah, it was very exciting. And you can see that's where Takapo meteorite was located. It had a mass of 810 grams, and that's right where we've modelled a mass of about 1 kg. So the modelling has done a pretty good job of tracking this one down.
A rock that's travelled through space for billions of years, lit up the sky as it hurtled down to Earth, and with some amazing technology, a bit of guesswork, and incredible luck, it was stumbled across within a few minutes of the start of the search.
Were you part of the search area?